So I just wanted to go over the first couple of questions on the data analysis, day 3 of the bottle rocket investigation. And in particular, I'm going to talk about this in class, but there's a couple things to keep in mind as you're looking at your data and what you're actually seeing in the data. Because depending on how you recorded and how you went about the experiment, your data table might look different and might not have exactly the numbers you need. So we need to make a couple of adjustments in here. And then I want to show you roughly how to make the graph. It's important to note here that I did use 2 grams of baking soda, but I used different amounts of vinegar than you guys did. So you can't just take this data and use it, but the process of creating the graph will be the same. It's just that you're going to be using different numbers. So I just wanted to put that out there. So we're going to create a graph, and the axes, right? So on the y-axis, we have vinegar, the amount of vinegar that you used. And on that's the x-axis. And on the y-axis, we have CO2 produced. Okay, so the reaction that you actually saw was a combination of things. There's a reaction between the baking soda and vinegar that creates some products, and then one of the products of that reaction breaks down, decomposes more or less immediately to produce water and carbon dioxide. And it's ultimately that last part with the carbon dioxide that we're concerned with, because that's what creates the gas and the bubbles, and that is what we will be using to create the pressure, which ultimately will propel the bottle rockets that we're going to make. So we're trying to find, with the experiment that we did, what's the best ratio of vinegar to baking soda to produce the most gas possible without any extra. So it's sort of the stoichiometric ratio. What's the ideal mix? Because if you don't use enough vinegar, then you're not producing as much gas as possible, so you won't get as much thrust. If you just add, an unlimited amount of vinegar, figuring you'll use up all the baking soda, that doesn't help, because every bit of vinegar that you add increases the mass of the rocket. So you're either getting less thrust if you don't put enough vinegar, or too much weight if you put in too much vinegar, which kind of has the same effect. It means your rocket won't go as far as it could. So we're going to use the data that we collected and the graph that we're going to make from it to decide what is the ideal ratio. And again, your information will vary from mine because I'm using different amounts and things like that, but the process will be the same. So we're going to take the amount of vinegar, and even though, again, your numbers are going to be different. So I'm just going to do trial 1, trial 2. So I'm not going to put the amounts in, but when you do this, the numbers that you're going to put on the x-axis will be the actual amount of vinegar that you used in each trial. So again, some people might have used 5, some used 3 or 4, some might have used 10. So whatever numbers you used for the amount of vinegar each time, and then the total is going to be what you put in here. But I'm just going to say trial 1, 2, 3, 4, 5. How high did I get here? I got up to 8, 6, 7, 8. Okay, and the numbers aren't there. The actual amount of vinegar isn't there, but it's the vinegar in each trial. And then going up here, I'm going to have the amount of CO2 produced, and that's the total amount. And I'm going to go, let's see if I can do it, 0.1, 0.2, and so on. That's 0.3, 0.4, 0.5, 0.6, 7, 0.8, 0.9, and 1. Okay, so the scale's a little bit off at the top because I didn't give myself enough room, but you get the idea. So here's what we've got. Trial 1, the amount of vinegar we put in for trial 1 produced less than 1/10 of a gram. So the data point for that is going to be somewhere around here. Okay. In trial 2, and we produced 0.17. Keep in mind that the amount that you produce in each trial has to be added to all the amounts that you produced before, because we're kind of doing a bunch of things in one bottle. So even though we only produced 0.17 in this example in the second trial, if we had put it all in at once, we would have produced a total of 0.2. So that's what this last column is over here. It's taking the amount in each trial and adding it to all the trials before it. So you can see this number goes up each time, and it goes up by adding these numbers together. Okay, so this is the total of all the trials put together each time. Okay, so the second trial, again, we went to 0.2. Third trial, we went up to 0.5. Obviously, I'm not using graph paper, so this is a little bit off. Trial 4 was 0.55, so that only went up a little bit. Put that there. Trial 6 jumped up again. Or wait, what am I on? Trial 5 jumped up. And then trial 6 stayed the same. Trial 7, trial 8. Okay, so you can see there's sort of a trend here. And this one in trial 4 is definitely an outlier, because what you'll see is that if you now connect these dots, right, you should get more or less something that looks like a straight line up to about here. And then from there, it flattens out, more or less. Again, there's some error in here. Obviously, something happened in that trial number 4 that makes that an outlier. But if we follow the trend, it goes up more or less by the same amount each time, until you get to trial 5 right here, and then it stops going up. Essentially, there's some little variation there, but if we kept doing it more and more and more, this number really wouldn't change, other than some minor fluctuation. That's just that there was a drop too much or not a drop enough of vinegar. Since I'm not measuring the vinegar each time, I'm just assuming it's exactly the right number. So there's a little bit of wiggle room there. Okay, so there's what your graph will look something like this. Your slope and angles and things will be a little different because you're using different numbers. So your mass produced will be different. Your amount of vinegar each time will be different. So the scale and the scope of your graph will look different, but your overall shape should be something like this. So what does that mean? It means that, as we said in the some of the previous questions and things we've talked about in previous lessons, the graph is showing that there is a limit to how much gas can be produced. Okay, we can't just add vinegar infinitely and produce more and more gas, because we run out of baking soda. We had a limited amount of baking soda that we started with, and we slowly used that up by adding more and more vinegar until it basically ran out and stopped reacting. So that's what the change implies, right? That you have reached the limit of the limiting reactant, which is the baking soda. So what is the ideal ratio? How are you going to figure that out? I didn't put the numbers in here, but let's just say, remember we had 2 grams of baking soda, and I'm just going to make up a number. It's going to be different from yours. Let's say we find that the point at which it stops going up is when you added 75 grams of vinegar. Okay, that's the break point. Vinegar, that's a G. Okay, that point is the point at which you've made as much as you can with that amount of baking soda, and adding any more vinegar just adds weight. Okay, so let's say that's the point at which the slope changes. You would see that our ratio is 75 to 2 or 2 to 75. And then if I wanted to simplify that, it would be 1 to 37.5. 1 gram of baking soda for every 37.5 grams of vinegar. Okay, so with my kind of made up example here, that would be the ideal ratio. For every gram of baking soda, you want to have 37.5 grams of vinegar, or for every 37.5 grams of vinegar, you want to add 1 gram of baking soda. That gives you as much gas as you can possibly make with that combination before the baking soda gets used up. There's no extra vinegar. There's enough vinegar to use all the baking soda and no more. So then the second question here is, we're going to add 500 milliliters of vinegar. So in our experiment, we used, somewhere between, 30, 40, 50 grams before we used it all up. And I'm saying it's 37.5 grams, so I'm using a different number. We want to then project that number out to 500 milliliters of vinegar, which is 500 grams. Okay, so if we have the ideal ratio of 1 to 37.5, right, or 2 to 75, same thing mathematically, then we want to know if we have 500 grams of vinegar, how many grams of baking soda should we use? What would be the perfect amount of baking soda for 500 grams of vinegar? So we'd cross multiply and we'd have 500 divided by 37.5, which comes out to, I don't know what. Because I'm making these numbers up. 37.5 divided by 500. Oh, I did that upside down. 500 divided by 37.5 would be 13.33 grams of baking soda. Okay, so according to, again, my made up numbers, I promise you this is not the actual ratio that you'll want to use. According to the information that I gave you and the steps that you will take using your own numbers, in our bottle, we're going to put in 500 milliliters of vinegar and 13.33 grams of baking soda, and that will give us the perfect mix of baking soda and vinegar to maximize our gas without adding any extra weight. So that's how you're going to do this. These numbers will be different. This side will be the same, but you're going to set it up like this. Just plug in your ratio of baking soda to vinegar from your graph in that side. The x over 500 will be the same. You'll cross multiply and divide to find out what your ideal ratio is. Okay, and then the remaining questions in this packet I will leave to you to work through. All right, so there you go. I just wanted to go over that. And also, I forgot to go back here, the table, depending on how you collected the data. All right, so we start with a certain amount of baking soda, a certain amount of vinegar. We get a total amount that we started with. After the reaction, we get the final mass which you recorded. And then what some of us did as we were doing this is we said, okay, so the second time we have still the same 2 grams, and now we have 17 grams of vinegar. So we would have said this is, 18.9, which is almost what it came out to because there wasn't much product in that first one. But the idea here is you need to, instead of doing that, you're going to take this number and then add how much vinegar you added. Then take this number, add how much vinegar you added, so that the end mass of each trial becomes the starting mass of the new trial plus how much vinegar you added.